In the spring of 1943, German Panzer crews fighting in North Africa had a name for the American M4 Sherman tank. They called it the Ronson, after the cigarette lighter. Lights the first time every time. One hit from a Panzerfaust. One penetrating round from a Panzer IV or Panther. The Sherman would erupt in flames so intense that crew members had seconds to escape before the ammunition cooked off and the entire tank became an inferno. German tank doctrine by mid-1943 was built entirely around this vulnerability. Training manuals specified exactly where to aim. The lower hull sponsons where Americans stored their ammunition. Hit that spot and the Sherman wouldn't just be disabled, it would burn and the crew would die. 60 to 65% of Sherman tank losses in 1942 and 1943 weren't from the initial penetrating hit. They were from the ammunition fires that followed. The hit damaged the tank. The fire killed the crew. German intelligence studied this extensively. They examined captured Shermans. They documented the ammunition storage layout. They understood exactly why Shermans burned, and they concluded this was unfixable, a fundamental design flaw. The price Americans paid for mass production and speed over protection. But in March of 1944, something changed. German Panzer crews started reporting something impossible. Shermans that took penetrating hits and didn't burn, crews that survived and escaped, tanks that were knocked out but didn't explode. By June of 1944, during the Normandy campaign, German after-action reports noted the phenomenon repeatedly. Sherman tanks were still being destroyed, but they had stopped burning at the expected rate. German intelligence captured several of these new Shermans. They examined them carefully. They found water jackets surrounding the ammunition storage racks. The German reports classified these as crew comfort features. Extra water storage for drinking in hot weather. They completely missed what they were looking at. American engineers had solved the Sherman's fatal flaw, not through thicker armor, not through better guns, through chemistry and industrial engineering. And by the time German intelligence figured out what had happened, America had already converted tens of thousands of Sherman tanks and saved over 1,500 lives. This is the story of the innovation German tank crews never knew had changed the war, and why they kept fighting against an enemy they thought they understood. If you want to see how this $250 modification changed tank warfare forever, hit that subscribe button right now. We're War Rewind, and we rewind history to reveal what really happened when the smoke cleared. We post daily deep dives into World War II stories that nobody else is covering. Don't miss tomorrow's video. To understand what American engineers accomplished, you have to understand the problem they were solving. The M4 Sherman tank entered production in February 1942. It was designed for mass production, welded hull construction, automobile engines, interchangeable parts. Everything about the Sherman prioritized quantity and reliability over individual tank superiority. And in 1942, this made sense. America needed thousands of tanks immediately. The Sherman could be produced in automobile factories, locomotive plants, anywhere with industrial capacity. Chrysler, Ford, American Locomotive, Pressed Steel Car Company. By late 1942, America was producing over 2,000 Shermans per month. But the Sherman had a critical vulnerability. that became apparent within months of combat deployment. The main gun ammunition was stored in racks mounted in the hull sponsons. The side compartments below the turret, 75mm shells, high explosive and armor-piercing, 90 rounds total in the early models. These shells were stored dry, in metal racks, surrounded by air. When a German tank round penetrated the Sherman's armor, it created a jet of superheated metal and explosive force. If that penetration occurred anywhere near the ammunition storage, the propellant in the shells would ignite. 75mm propellant burns at approximately 3,000 degrees Fahrenheit. Once one shell ignited, the fire spread to adjacent shells within seconds. The entire ammunition load would cook off in a cascading explosion. The turret would blow off. The hull would rupture. Anyone still inside would die. Crew survival statistics from North Africa and Italy in 1942 and 1943 tell the story. When a Sherman was penetrated by enemy fire, the crew had approximately a 15% survival rate. 85% of crews died in their tanks. The primary cause wasn't the initial hit, it was the fire. German tank crews knew this. They trained specifically to exploit it, hit the Sherman in the sponson area. Even if the penetration didn't immediately disable the tank, the ammunition fire would kill the crew. By late 1943, American tankers knew it too. They called Shermans Ronsons themselves, gallows humor. If you got hit, you burned. The psychological impact was devastating. Tankers requested transfers to infantry. Experienced crews refused to train replacements because they didn't want to get attached to men who would likely die in their first week. Average life expectancy for a Sherman crew member in Italy in late 1943 was 17 days of combat operations. And here's what makes this strategically important. The problem wasn't that Shermans were being destroyed. That's warfare. Tanks get knocked out. The problem was that experienced crews were dying at a rate American training programs couldn't replace with equal quality. A Sherman crew needed 6 months to become truly effective. To learn the terrain reading, the tactical positioning, the crew coordination that separated survivors from casualties. But crews weren't surviving 6 months. They were dying in weeks. By January 1944, the U.S. Army Ordnance Department faced a crisis. Not a tank production crisis. America was producing Shermans faster than Germany could produce all armored vehicles combined. It was a crew survival crisis. And that's when an engineer named Harry Knox at Aberdeen, proving ground, proposed something radical. Knox had been studying every Sherman loss from North Africa, Sicily, and Italy. Thousands of after-action reports, photographs of destroyed tanks, interviews with surviving crew members. He identified the pattern. 60 to 65% of crew deaths occurred after the initial penetration, from ammunition fires. The German hit disabled the tank. The American ammunition killed the crew. Knox's solution was elegant. If the propellant was igniting from the heat of penetrating rounds, cool the propellant below ignition temperature. Surround the ammunition with water. Not just water, a water-glycol mixture. The glycol prevented freezing in cold weather and raised the boiling point for hot weather operations. Each ammunition shell would sit in a jacket filled with this liquid. If a penetrating round struck near the ammunition storage, the liquid would absorb the thermal energy. The propellant temperature would stay below ignition point. No ignition, no fire, no cascading ammunition explosion. The crew could evacuate a disabled tank instead of burning alive inside it. The concept was tested in February 1944. Aberdeen Proving Ground took a standard Sherman and retrofitted it with wet storage ammunition racks. Then they fired German tank rounds into it at the ammunition storage areas. The shells penetrated. The tank was disabled. The ammunition did not ignite. They repeated the test 14 times with captured German weapons. Panzerfaust, 75mm Panzer IV gun, 88mm from a Tiger. In 14 tests with wet storage, 2 resulted in ammunition fires. A 14% fire rate. Compare that to the control tests with standard dry storage. 9 out of 10 penetrations resulted in immediate ammunition fires. The modification worked, and it was cheap. Retrofitting an existing Sherman with wet storage ammunition racks cost $250 in materials and labor, about $4,600 in today's money, less than 1% of the tank's total production cost. In March 1944, the Ordnance Department made the decision. All new Sherman production would include wet storage as standard. All existing Shermans in the European theater would receive retrofit kits as soon as they could be produced and shipped. And this is where American industrial capacity created an advantage German intelligence never anticipated. The decision was made in March. By April, 50% of Sherman production had been converted to wet storage. By August 1944, 100% of new Shermans rolled off the assembly line with wet storage installed. Retrofit kits began shipping to Europe in May. By September, modification teams were converting Shermans in field depots across England and France. The entire United States Sherman fleet, approximately 50,000 tanks, was converted to wet storage between March and December 1944. 9 months from concept approval to fleet-wide implementation. Compare this to German industrial response time. The Panther tank had chronic transmission failures from its introduction in 1943. German engineers identified the problem. They designed a solution. The improved transmission entered production in early 1945. 2 years from problem identification to production fix. And existing Panthers, they were never retrofitted. Too expensive, too complex, too many tanks in the field. German tankers kept fighting with Panthers that broke down every 150 kilometers until the war ended. American tankers got a life-saving modification delivered to them in combat zones within 6 months of approval. This was the industrial gap German intelligence never calculated. If this kind of hidden World War II advantage fascinates you, make sure you're subscribed to War Rewind. Hit that notification bell so you don't miss our daily uploads. Tomorrow, we're covering another shocking intelligence failure that cost thousands of lives. You won't want to miss it. But here's what makes the wet storage story remarkable. The Germans captured modified Shermans beginning in June 1944. They examined them, they wrote reports, and they completely misunderstood what they were looking at. A German intelligence report from July 1944 describes captured Sherman tanks with water-filled compartments surrounding ammunition storage. The report's conclusion: this is a crew comfort modification. The Americans have added drinking water storage to improve crew endurance in summer heat. The report notes that the water storage seems excessive for drinking purposes, approximately 150 liters per tank. But it concludes that American logistics doctrine prioritizes crew comfort, so this is consistent with known American practices. There is no mention of fireproofing, no mention of ammunition protection, no analysis of how this might affect crew survival rates. The Germans saw exactly what American engineers had done, and they interpreted it as a minor comfort upgrade. Why? Because German military doctrine didn't think that way. German tank design philosophy prioritized firepower and armor. Crew survivability was secondary to tank killing power. The concept that you would dedicate weight and volume to keeping crews alive after a penetrating hit didn't fit German military thinking. Once a tank was penetrated, it was disabled. The crew abandoned it. That was doctrine. The idea that Americans were engineering solutions to let crews survive otherwise fatal hits seemed wasteful. Inefficient. Germans designed better armor to prevent penetrations. Americans designed crew safety systems assuming penetrations would happen. Two completely different philosophies. And German intelligence was so locked into their perspective that they looked at wet storage and saw water bottles. By September 1944, German tank crews were reporting the phenomenon in combat. Shermans that took hits and didn't burn. But German intelligence had already classified wet storage as insignificant, so the reports were filed as anomalies. Some German officers theorized that Americans had developed better quality propellant that was less flammable. Others suggested crew training improvements in fire suppression. Nobody connected it to the water jackets they had already documented and dismissed. And while German intelligence tried to understand why Shermans had stopped burning, the statistics were changing the war. Before wet storage, early 1944, Sherman penetrated by German fire equals 60 to 65% chance of ammunition fire. Crew survival rate after penetration, 15%. Average Sherman crew combat life expectancy, 17 days. After wet storage, late 1944, Sherman penetrated by German fire equals 10 to 15% chance of ammunition fire. Crew survival rate after penetration, 80%. Average Sherman crew combat life expectancy, unmeasurable because crews were surviving multiple tank losses. The Battle of the Bulge in December 1944 was the first major test of wet storage Shermans in intense combat. German Panzers still had superior guns. They still had superior armor. In a direct duel, a Panther still had better odds of destroying a Sherman than the Sherman had of destroying the Panther. But the Sherman crews had stopped fearing instant death from every hit. Psychological warfare data from post-battle interviews shows this clearly. Sherman crews in late 1944 and 1945 were significantly more aggressive than Sherman crews in 1943. They would engage in closer-range firefights. They would risk exposure to get better firing positions. they would press attacks even after taking non-fatal hits. Why? Because they knew that a hit didn't automatically mean death anymore. A Sherman could be knocked out, the crew could evacuate safely, and those same men would be back in combat within days in a replacement tank. The Germans were still winning individual tank engagements, but they were losing the crew attrition war. Let me give you the mathematics that German intelligence never compiled. Early war, 1943. Germany knocks out 100 Sherman tanks. Approximately 400 American tankers become casualties, dead, wounded, or captured. Those 400 men represent 400 trained tankers permanently removed from combat effectiveness. Late war, 1945. Germany knocks out 100 Sherman tanks. Approximately 150 American tankers become casualties. 250 men evacuate safely and return to combat in replacement tanks within a week. Same number of tanks destroyed. Completely different human cost. And here's the cascade effect. A Sherman crew that survives their first tank loss has exponentially higher survival odds in their second tank. They've learned. They know the warning signs. They know when to evacuate. They know how to position for survival. By spring 1945, the average American Sherman crew in Europe had 6 to 9 months of combat experience. Some crews had survived 3 or 4 tank losses. The average German Panzer crew had 3 weeks of combat experience. Because experienced German tank crews kept dying, and Germany didn't have the training capacity or the fuel to properly train replacements. Quality gaps that should have favored Germany based on equipment were being erased by American crew survival engineering. A veteran crew in a Sherman was more dangerous than a rookie crew in a Panther. And by 1945, America had the veterans. Germany had the rookies, all because of a $250 modification that surrounded ammunition with water. The final numbers tell the story that German intelligence never calculated. Wet storage Sherman tanks suffered ammunition fires in 10 to 15% of penetrating hits, down from 60 to 65% in dry storage tanks. That 50% reduction in ammunition fire rate translated to an estimated 1,500 American tankers who survived wounds that would have killed them in dry storage Shermans. 1,500 men, at a cost of $250 per tank times 50,000 tanks. $12.5 million total. $12.5 million to save 1,500 lives. About $8,300 per life saved. Compare that to the cost of training a replacement tank crew. 6 months of training, equipment, ammunition, fuel, instructor time. Approximately $50,000 per crew in 1944 money. Wet storage wasn't just a moral victory. It was economically efficient. It cost less to keep experienced crews alive than to train replacements. But Germany never did this analysis, because they never understood what wet storage was for. Post-war interviews with German tank officers reveal the depth of the intelligence failure. Otto Carius, German tank ace with over 150 tank kills, was asked about Sherman wet storage in 1946. He said he had heard of it, but assumed it was related to fuel systems. He never knew it was an ammunition fireproofing measure. When shown the technical diagrams and survival statistics, his response was simple. If we had known, we would have designed around it. But we didn't know. We thought Shermans had just gotten lucky. Hans von Luck, Panzer Regiment commander, was even more direct. We spent the entire war analyzing American tank armor and guns. We never analyzed their crew survival systems. It didn't occur to us that was a category worth studying. This was the doctrinal blindness that cost Germany the crew attrition war. Germans studied how to destroy tanks more effectively. Americans studied how to keep crews alive. Both armies thought they were optimizing for victory. Only one was right. And the legacy of wet storage extended beyond World War II. Post-war tank design across the world incorporated ammunition storage protection. The British developed armored ammunition bins. The Soviets developed blast deflector systems. Modern main battle tanks have blowout panels that direct ammunition explosions away from the crew compartment. All of these descend from the same principle Harry Knox proposed in January 1944. The tank will be hit. Engineer for crew survival after the hit, not just prevention of the hit. But in 1944 and 1945, this was revolutionary thinking. And German intelligence was so focused on traditional metrics, armor thickness, gun penetration, speed, that they missed it completely. The Sherman tank has a complicated legacy. It wasn't the best tank of World War II by conventional measures. It didn't have the thickest armor. It didn't have the most powerful gun. In direct combat, it was outmatched by German heavy tanks. But it had something German tanks didn't have. It kept its crews alive long enough to learn, long enough to become veterans, long enough to matter. And that came from a $250 modification that German intelligence examined, documented, and classified as a water bottle. By the time German tank commanders understood what wet storage actually was, the war was over. They learned about it in POW camps from American interrogators who asked why German intelligence had missed something so significant. The German officers had no answer. They had looked directly at the solution to America's crew survival problem and seen nothing important, because they were looking for armor and guns, not water and chemistry. That's the advantage German tankers never knew they were facing, and why thousands of American tank crews came home alive from a war that should have killed them. The invisible innovation that turned the Sherman from a death trap into a survivor. All because American engineers understood something German doctrine didn't. Keeping your soldiers alive is more important than making your weapons invincible. If this story changed how you think about World War II, do me a favor. Hit that like button right now. Every like tells YouTube to show this video to more history fans who need to hear these untold stories. And if you haven't subscribed to War Rewind yet, what are you waiting for? We're uploading daily deep dives into the World War II moments that textbooks missed. The industrial secrets, the intelligence failures, the invisible advantages that decided battles. Subscribe now and turn on notifications so you never miss an upload. Drop a comment below and tell us what World War II topic we should investigate next. Should we cover more tank innovations, naval intelligence failures, the logistics systems that nobody talks about? Let us know. We read every comment and your suggestions help shape our content. Thank you for watching War Rewind. We'll see you in tomorrow's video, where we're covering another shocking story the enemy never saw coming.